The technical quality of television production has improved significantly over the past few years, to the point where an artist can now communicate ideas without the system getting in the way. Accurately reproducing those ideas, allowing you to experience the intentions of the artist, requires careful tuning of your audio-video system. There is a correct setup to present information contained in the audio and video signals. Following the setup instructions provided by most consumer equipment manufacturers won't always get you the best possible results. For example, some TV set manuals tell you to adjust the front panel controls until the picture looks good. If you don't know exactly what the picture is supposed to look like, it's difficult, if not impossible, to properly adjust the controls. Video Essentials provides a reference for correctly adjusting the easily accessed controls for both audio and video components, so that what you see and hear in your home theater system is closer to the program's original intent. Along the way, you might find that your system doesn't have all of the features or capabilities needed to get the picture and sound exactly right. Some of these shortcomings may be unimportant to you. Those that are important may be overcome by a qualified service technician. Contact the manufacturer or an authorized service center as a first step in obtaining help. You may discover that more detailed adjustments in the video system are required, such as the color of gray, convergence, or picture geometry. Your best bet for this type of service is to contact an independent home theater installation company. They can often do more for you than a repair center. Organizations such as the Imaging Science Foundation can provide you with a list of specially trained people in your area. You'll find current information about them in consumer magazines covering the laserdisc and home theater market. Some problems can only be fixed by replacing equipment. In any event, do not attempt to go beyond the consumer accessible controls without engaging qualified help. You've probably noticed that no two people seem to set the TV controls the same way. To make matters worse, people often turn knobs without knowing what the individual controls will do to the picture. This is part of Video Essentials, an explanation of how each control changes the picture. Did you know that the brightness control is used to set the level of the dark parts of the picture? Or that the contrast or picture control sets the peak light output? Or that the sharpness control usually distorts the picture as it is increased? Most of the television audience has not been told how to correctly adjust these controls. There are several reasons for this. First, properly setting these controls requires the use of test patterns, and not just the ones you can find late at night on your local TV station. Second, even if you have the test patterns, you need to know how to use them, including how to detect and compensate for any errors your set might be introducing into the picture. Most properly calibrated TVs, new or old, can't begin to compete with ambient light hitting the front of the set. This extra illumination will wash out the picture. As you'll see later, increasing the contrast control in an attempt to compete with a lot of room light will destroy the quality of the picture. No TV set manufacturer is willing to advertise that getting the best picture possible from their set requires tight control over ambient room light. Yet they all have this limitation. When watching a regular TV set, which normally occupies only a small portion of your field of view, some room light is needed to reduce eye strain. Putting that light behind the set will help keep it away from the surface of the picture. Once light is on in the room, the color of the light, its intensity, and the color of the walls around the set become important. It's no wonder a lot of this information has been held back. There are a lot of conditions to be met in achieving an ideal viewing environment. Taking the need to control the color of the wall behind the set as an example, our perception of color is relative. The color of the environment of an object will play a significant role in our determining the color of the object itself. Now, once you recognize this, you'll know that the environment of the monitor is just as important to a good picture as properly adjusting the controls on the set. In an ideal viewing environment, the color of the light behind the set should be about the color of daylight, or D6500 Kelvin, and no higher in intensity than 10% of the peak light coming from the monitor itself. While the surface areas around the set should be neutral or nearly neutral in color, they don't need to be uniform in shape or uniform in intensity. If all of this 10% stuff sounds confusing, we've provided a reference pattern for maximum ambient light level behind the TV set in the Video Test Signals chapter. Keep in mind that it is only useful after your set has been properly calibrated. Just make sure the light behind the set doesn't look any brighter than the reference pattern. If you own a large-screen front projection system, you've probably already discovered that it won't tolerate any ambient light in the room. The picture is usually dim enough and occupies a large enough area of your field of view that light level changes in program material won't create eye strain. As in any movie theater, you should be able to completely close all drapes or window coverings and turn the room lights off. There is at least 40 years of misinformation or total lack of information about properly viewing a TV set to undo. This again is part of Video Essentials. Before getting to the audio and video adjustments, let's take a short tour of what we will be covering. The video controls we'll be highlighting include brightness, contrast, color, tint, and sharpness. Your set may label these functions with different names. As we introduce the adjustment procedure for each control, we'll provide a list of alternate names that might be used on your set. Since TV sets and projectors need at least a half hour to warm up before any video adjustments are made, we'll go through the audio system first. If your video system is already warmed up and you want to start with those adjustments, skip forward to Chapter 9. When reproducing program material, high-fidelity sound is just as important as great-looking video. The speaker system shown here reflects some of the changes that have taken place in home theater systems over the past few years. Certainly, the number of speakers has grown from the conventional stereo system. This home theater configuration is designed to recreate the ambience and sound quality of a high-end movie or television mixing stage. The sound quality achieved in the program mastering process can now be heard at home. You should be starting with at least a good 2-channel stereo system. If you'd like to go further and experience the multi-channel sound available from Dolby Surround sound encoder programs, you'll need additional speakers, coupled with additional channels of amplification, and Dolby Pro Logic decoding. The Dolby Pro Logic decoder provides a separate center channel output with enhanced steering logic for greater channel separation. The center channel was not part of the original passive matrix Dolby Surround sound consumer system. The current generation of Pro Logic decoders provide 4 separate channels of information: left, center, right, and surround. These 4 channels of audio are then amplified and routed to the appropriately placed speakers. Additional analog or digital signal processing may also be incorporated. The Lucasfilm Home THX audio system is an example. It's designed to assist you in more accurately reproducing the film studio mixing stage experience. This is accomplished by specifying the quality and nature of components used after the Dolby Surround decoding process. It includes additional signal processing to more accurately translate the mixing studio's sonic character into the home. The left, center, and right speakers are of specific and equal sound quality. The power output from the amplifiers is sufficient to allow all 3 channels to play simultaneously without distortion. We'll start our sound system tour in the stereo mode. You'll need your audio system remote control close at hand for the next few steps of the demonstration. If you have a more complex home theater audio system, place it in the stereo mode now, bypassing any Dolby Surround decoding or THX processing. If you haven't already done so, take a seat in the middle of your listening area. While you're seated in the best spot in the house, I'll move around the system, demonstrating some of its capabilities. With you seated in the center and listening to the system in the stereo mode, my voice should sound as if it's coming from a point in space between the left and right speakers. I'm going to move over to the left side of the room for a moment, making this a one-sided conversation. I should now be distinctly on the left side. So you know that I don't play favorites, I'll move back through the center and on over to the right side, right over here, right? Now that we've tested the right channel, I'll move back to the center. Once firmly back in the center, I'll attempt to get lost in the room. Did I say get lost? It should have been easy to follow me as I moved right up front. If I see the system is weighted properly, it should now be difficult to pinpoint my location. Let me find my way back up front. My position in the room should once again be easy to determine. For comparison, I'll take another turn at getting lost in space, staying there for a moment. Then return to the center. If you had been listening to this with your surround decoding on, you'd find that I had actually moved to the back of the room instead of getting lost. If any of these conditions of sound location seemed incorrect when listening in stereo, you'll want to check the connections of the components for correct left-right assignments and correct polarity of loudspeaker connections. There are audio test signals coming up that will better help you determine if the system is wired properly. In the stereo mode, my voice should sound as if it is coming from the center of your system, between the left and right speakers. If you have a Dolby Pro Logic decoding system, turn it on now. Once switched on, my voice should be coming directly from the center speaker. With Dolby Surround decoding, I can easily move to the back of the room. If you were to return to the stereo mode, my voice would once again take on the diffuse and directionless quality you heard earlier. My location in the room would be much more difficult to determine. But we're getting ahead of ourselves. Let's get a more complete tour of the home theater audio system capability before making any of the necessary tests and adjustments. Dolby Pro Logic utilizes 3 front speakers, left, center, and right. In this example, we've gone a step further by using the same model of loudspeaker for all 3 positions. Unlike many conventional stereo speakers, these are also magnetically shielded so they won't distort the picture on your TV set. We've added subwoofers along the sidewalls to handle all of the low bass information. The main concern in deciding where to place these speakers is finding a spot where the bass response at the primary listening area is flat. Poor placement of the subwoofers will make some bass frequencies seem much louder than others. You'll most likely find that the ideal subwoofer placement will be different from that shown here. That's something you'll have to determine by experimentation. Seeing them in such a location in our room is intended to encourage you to try various subwoofer placements in your room. The surround speakers we're using are placed well above the listener. They are different in design from the front-firing speakers often found in surround sound systems. These speakers are dipolar. They fire sound energy into the room rather than directly towards the listener. With these speakers, the minimum sound radiation area, the null point, is aimed at the listening area. This configuration can accommodate audience members seated over several rows in the room. It also aids in creating a diffuse sound field similar to that in a movie theater. This type of surround speaker is specified in a THX certified system, but will work equally well in a standard Pro Logic setup. The surround information coming from the Dolby Pro Logic decoder is monaural, not stereo, even though separate left and right outputs are provided. It is also band limited, containing little or no low bass information or much high-frequency sound above 7 kHz. A Dolby Pro Logic decoder with THX enhancements does provide separate decorrelated sound to the left and right surround speakers. The subwoofer output of a Dolby Pro Logic or THX certified system is usually monaural, with no separate left and right indications. In installations containing 2 subwoofers, a single channel of amplification is all that is usually necessary for both speakers. Dolby Pro Logic decoders have 3 options for the center channel: phantom, normal, and wideband. They are selected with the center mode switch. The phantom mode is used when the system does not include a center speaker or when you wish to shut off the center speaker. In this mode, center channel information is sent equally to the left and right channels, creating the illusion of a virtual sound source midway between the left and right when the sound image should be centered. In the normal mode, bass information is routed to the left, right, and/or subwoofer outputs. It is not sent to the center channel. Use the normal mode if your center speaker is not capable of reproducing deep bass sounds. In the wideband mode, a full bandwidth signal is provided to the center channel. Select the wideband mode when the center channel speaker is capable of deep bass response with or without an additional subwoofer. It should also be used if you have a speaker system meeting all of the home THX requirements. Up to this point, we've been discussing the two-channel PCM digital audio tracks on this disc. Audio on these tracks is discrete stereo during the stereo demonstrations, or Dolby Surround sound encoded for the majority of the program. There are also a number of discrete 5.1 channel digital audio systems available on this disc. They each provide the 5 independent full bandwidth channels of audio available in many movie theaters. The 5 main channels are designated as left, center, right, left surround, and right surround. The remaining 0.1 channel is an effects track containing low bass information. This track can be programmed to be completely independent of the other 5 channels or contain some of their low bass information. Since the channels are independent, they can be used for other purposes, such as multiple narration tracks, conveying 2-channel Dolby Surround encoded information, true stereo, or even monaural sound. A digital decoder is required to take advantage of this information. Each DVD player has a capability of processing at least one of these systems. Codes in these 5.1 channel systems can be used to switch the decoder among the many options we've mentioned. Most of the audio for this program has been mastered in the 5.1 channel system. A separate 4-channel mix is made from the 5.1 master, which is then Dolby Surround sound encoded to the 2 stereo channels found on the PCM digital audio tracks of this disc. Decoding all of the 5.1 channel systems will require external processing. The individual system to be decoded is selected using the player's remote control. Its output can be found at the bitstream connector on the back of the player. The player's internal processing may provide a 2-channel analog output for the selected audio. In the audio test signals coming up, you'll find that the surround test lasts longer than the 3 front channels, so that there is time to individually address the left and right surround channels in the multi-channel tracks. That's it for the audio system tour. It's time to begin the audio adjustments. You'll need the remote controls for the audio system, DVD player, and monitor close at hand. The program will automatically come to a stop ahead of key adjustments to let you get the appropriate remote control ready. We'll put operation symbols in the picture to guide you through the steps of the program. The main symbols used here are forward to the next frame, reverse to the previous frame, and play. The program index frames coming up will provide you with an opportunity to check out the operation of the player. In addition, there are several points in the test signal sections where you may want to continuously repeat signals. Many DVD players will accommodate this with an A-B repeat capability. Consult the player's manual to find out how to access this capability. It may not be obvious by looking at the buttons on the remote control. The A point of the repeat will be designated with an A in the lower right corner. This is where you start the repeat function. The A will go away as the test gets started. Once it's completed, a B will appear in the lower right corner. This is where you end the repeat function. You may have to press play to start the repeat once the A and B points are set. We'll start by verifying the stereo system connections, this time using test tones. Set your audio system's decoder to the stereo mode. The surround capability should be bypassed. Make sure the volume control is set at a moderate to low level, as these test tones can be difficult listening material, plus having the potential to damage your loudspeakers. On-screen graphics will pinpoint where the sound should be coming from. If the tones don't match the on-screen indications, check your system connections first. If the left and right channels are reversed, check for consistent left and right connections throughout the system. If the image was not centered or diffuse at the appropriate times marked in the video, check the polarity of the speaker wiring. This test tone sequence may be put in an A-B repeat loop if you need more time determining the condition of your audio system. Once the stereo system connections have been verified, turn on the Dolby Pro Logic Surround sound mode. Speaker wire polarity for the surround channel loudspeakers will be verified once all of the levels have been set properly. Some Dolby Pro Logic decoders require the calibration of the input level to the decoder. If this adjustment is available, you will be asked to set the level coming from the DVD player to match the input requirements of the decoder. Most decoders are preset and don't call for you to make this adjustment. The owner's manual for your audio system will indicate how to make this adjustment if it is needed. If you have to check or make this adjustment, set the input level to the decoder for the 0 dB or reference mark on the input meters with the following tone. Set the player in an A-B loop around the test signal if more time is required. Don't forget to keep the main volume control low when making this adjustment. Now it's time to set the output channels of the Dolby Pro Logic decoder. It is easier and far more accurate to set these adjustments using an inexpensive sound level meter than trying to listen for exact amounts of sound from each channel. This is the Radio Shack sound level meter with an analog readout. It is also available with a digital display. There are other brands of SPL or sound level meters that will work equally well in this application. Start by making sure the meter is set up properly. The weighting switch should be in the C position, and the response switch should be in the slow reading mode. The range knob should be set at the 70 dB position for the final level adjustments. In the next 5 chapters, we'll present pink noise test signals that should each be adjusted to register plus 75 decibels on the sound level meter when holding the meter in the prime listening position. The meter should be held at arm's length, aimed up, slightly forward of a vertical position, and not turned towards any speaker during the tests. You'll probably want to stand behind the seat in order to hold the meter at arm's length and still have it in the primary listening area. When setting the level of the subwoofers, move the meter to the left and right of the primary seating area while still aiming it upward, and take an average of the area readings. All Dolby Pro Logic decoders have their own internal test signals. These internal test tones are great for getting the balance between speakers equal, but may not accurately represent sound levels coming from the source. If you have reason to use the internal signals, check your owner's manual for more information. The adjustments made with the following test signals check out your entire system from source to speakers. The level of the following test signals should produce a reading of plus 75 dB when the final adjustment is completed for each channel. Now that levels in the surround system have been calibrated, it's time to check the polarity of the center speaker. My voice and eventually the test signal should sound as if they are coming from an area between the left and center speakers. It's important to note that if the center speaker is not well matched to the left and right, the tone might not be accurately positioned between the two speakers. If the signal position is not clear from a well-matched set of speakers, first check to see that the speakers are wired properly. The plus terminal of each amplifier output connection for the left, center, and right channels should be connected to the proper speaker's plus terminal. One or both of the leads on the speaker wire are marked in any number of ways. Sometimes it is color-coded, or there might be printing or molding along an edge of the wire. If you've discovered the need to change connections, run this test again once the work has been completed. One more check of the center speaker polarity, this time between the center and right side. My voice and the following tone should appear to come from between the center and right speakers. Finally, it's another walk around the room in voice, starting over here on the left. As I'm walking around the room in a clockwise direction, my voice should sound continuous, even in both motion and volume level as it passes from speaker to speaker. If you are listening to this from one of the multi-channel tracks, you should be able to clearly hear me move across the back of the room. You can put this narration or the following test tones in an A-B repeat loop if you need more time to analyze the condition of your system. Test tones doing a similar circulation around the room are up next. Once that's completed, we'll move on into the video adjustments in the next section of this DVD. Here comes the circulating noise. Back at the beginning of the program, we showed you how important the environment of the monitor is to a good picture. As you adjust the TV's controls in the next few chapters, you'll better understand why it is so important. The first time through the adjustments might take a little getting used to, but once you've done it a few times, you won't need the instructions anymore. Once you've become an expert, go directly to Chapter 15 for the needed test signals. Most direct view and projection televisions use vacuum tubes as display devices. They take time to warm up. Your set should be on at least 30 minutes before making any final adjustments. Altogether, there are 5 user video controls on most TV sets. They are brightness, contrast, color, tint, and sharpness. We'll cover them in that order. Some or all of these functions may be labeled differently on your set. We'll fill you in on other names used for particular controls as we discuss each one. A number of sets have individual memory for each type of input, such as the antenna or cable connections, or any number of composite video or S-video inputs. You may have to adjust these controls for each input. Check your TV's owner's manual if you have any questions. Several of these controls interact with each other. Adjusting brightness, for example, will change contrast. You'll therefore be asked to go back and check previous settings once you've completed the current adjustment. You may have to go back and forth several times among adjustments before they are as close to correct as possible. We'll point out the most common control interactivity, but your set may behave differently. The test signals we expect you will need for rechecking prior adjustments will be included in every controls adjustment section. We'll start each control description with an introduction to the function. With an appropriate test signal in the background, the objective of the adjustment will be stated at the top of the picture, followed by a list of control names that might be found on your set for that function. The most common name heads the list. The most descriptive name for the control is underlined. A short explanation of the purpose of the control is followed by a list of test signals used for adjusting that control. Your set's engineering and/or manufacturing process may prevent it from properly translating a video signal into a visually correct image. Even if it can't do everything 100% right, the Video Essentials procedures will help you get as close to correct as your set will allow. One word of caution: have the remote control for your TV set handy. You may have to use it quickly during this sequence. If the contrast level is set significantly above where it should be, as is the case in many TV sets as they come from the factory, the white rectangle in this pattern may start to change color after a short period of time. If this happens, turn the contrast or picture control way down. It will be readjusted later. Assuming that your set is contrast safe, we'll go on with a discussion of black level. Black in a picture is defined as the absence of visible light. Any information at or below black in the video signal should not be seen in the picture. The plooge is a reference for setting video black at the point of absence of light in the picture. The plooge usually shares space in the picture with other test material. This particular configuration is suited for setting black level on a well-engineered display device. The most recognized placement of plooge is in the SMPTE color bar pattern. This is not the best choice of patterns because of the plooge's small size, poor location, and the high brightness level of surrounding information. Here, the plooge occupies a much larger area of the screen, and the accompanying grayscale doesn't interfere with its use. The plooge itself is made up of two stripes on a black background. This complete test pattern has a low average picture level. Let me simulate taking control of the black level adjustment on your set for a moment. We'll raise the black level to a point where both stripes show up against the background. The background in the test signal represents black in the video signal. The stripe on the left is darker than the background. It is below video black or blacker than black in video level. That's allowed in our television system. The stripe on the right is lighter than the black background. The proper way to set black level is to reduce the brightness control until the blacker than black stripe and black background of the picture just match in level, with the above black stripe still being visible. This works because black is defined as an absence of light. Therefore, blacker than black can't visually go below the absence of light. Depending on the brightness setting of your display device, the level of black you are now seeing may look gray. You'll be able to correct that in a moment. Properly adjusting the brightness control sets black level at a point where anything at or below black in the video signal won't be seen by the viewer, and anything above black will be seen. Here, the plooge signal is being displayed with a white bar. The complete picture has a high average picture level. Average picture level becomes important in black level adjustment because some sets tend to change the level of displayed black as the APL changes. We need to determine if your set is one of them. First, one more simulation of setting black. Then it's your turn. Remember, increase the brightness control until you can clearly see both stripes against a gray background. Then turn it back down until the blacker than black stripe and black background just match in level. The lighter than black stripe must still be visible. Initially, I'd like to have you use this high APL plooge test pattern so we can test your set for its ability to hold black at black independent of picture content. When you've finished making the brightness adjustment, press play to continue. Got it? Now let's switch back to the low APL plooge pattern. What happened to the level of black? It should have remained the same. If your set isn't good at holding black at black, the plooge pattern in the low average picture level signal went up. It became gray. Let's take another look. Before jumping to any conclusions about your set's ability to hold black at black, an excessive amount of contrast can also cause black to shift in level. We'll check that adjustment next. Once the contrast has been set properly, we'll again provide high and low average picture level pluged signals and let you switch back and forth to check your set's ability to hold black at black. If you find that your set is doing a good job of holding black at black, use the low APL pluged pattern for setting black. If it isn't holding black at a fixed level, then use one of these two high APL pluged signals as a test pattern when setting the level of black. If you need to check the setting of the brightness control again, the necessary test signals are coming up. Otherwise, go forward to the next section once you're comfortable with setting the brightness control. The peak white level of a display device should be set below the point of introducing noticeable distortion into the picture. There are two types of distortion we are going to consider. The first is a change in picture geometry causing straight lines to bend or the picture to change size as scenes change between light and dark. The second is picture blooming, where objects are slightly enlarged in size as they become brighter. When possible, the maximum level of white should be set below the point where either type of distortion occurs. We need to start by making sure the sharpness control is completely off, or at least at its lowest setting. We'll set it properly later. Peak white level should be set below the point where the line starts to bend. On some sets, the line will not bend at any point in the contrast range, and on other sets, there may be no point along the range where the line is straight. Try your hand at adjusting the contrast control. See if you can set it below the point where the line starts to bend. Take note of where the contrast control is positioned when you have finished. If the contrast level seems rather low, this is only the first of two tests. It may have to go down even further. Now you can see why ambient light in your viewing environment has to be tightly controlled. Peak white level on a TV set must also be set below the point of any blooming in the picture. Let's start by demonstrating the effects of blooming. Watch the size of the white rectangle as we simulate increasing, then decreasing the contrast level. The white rectangle gets larger in size when the picture is blooming. If you could turn the contrast up high enough, one by one, the rest of the rectangles would increase beyond their normal size. The proper setting of the contrast control is below the point where the top rectangle even starts to increase in size. See if you can find the point in the contrast range where there is no blooming. Some sets allow an extreme amount of blooming at the top end of the contrast range, and others won't allow the contrast to be set low enough to get out of blooming. Most sets allow at least some blooming at the top of the contrast range. Again, take note of the final position of the contrast control. Was there a difference in the position of the contrast settings between these two tests? Ideally, both conditions, no blooming and no distortions in geometry, should be satisfied by the final position of the contrast control. Not all sets are capable of this, however. If a compromise needs to be made to obtain a usable amount of light, do not exceed the point of blooming even if the line in the needle pulse is bending. In order to determine the true condition of your set, both the brightness and contrast controls must be properly adjusted. These two controls are usually interactive, so you'll have to go back and forth between them several times before getting both levels right. Don't worry, all of the patterns needed for both adjustments are coming up. When you've got them set properly, go on to the next set of adjustments. For most of the history of color television, consumers have been told to adjust the color and tint control so that flesh tones look good. While a few people might be good at guessing what an individual's skin color should look like, most of us never could get it exactly right. Then there are all of the other colors. If flesh tones are used as a reference for setting color and tint, will everything else look correct? In the professional world, SMPTE color bars are displayed as a test pattern for adjusting the color and tint controls. The function of these two controls is to calibrate the color decoding process. The decoder converts the NTSC signal into the three video signals, red, green, and blue, which are needed to drive the display. In adjusting these two controls on your set, first make sure that all automatic color and tint functions have been turned off. You'll need the blue filter included in this package when setting these controls. Let's first run a simulation so that you'll know what you should be seeing when you make the adjustments. The color control is adjusted so that when you look through the blue filter material, the level of blue in the blue patch matches the level of blue in the gray bar. The tint control is adjusted so that when you look through the blue filter, the blue in the cyan and magenta bars and their corresponding patches match in level. The color and tint controls are usually interactive. You'll probably have to adjust them several times before all of the bars and patches match in level. Once the blue only has been set correctly, the SMPTE color bar test pattern makes it easy to check the rest of the colors. If the decoder in your set is functioning properly, the bars in the red channel will all be equal in level, and the bars in the green channel will all be equal in level. Even with all of the automatic color functions turned off, most color decoders do not function properly. The amount of red in the red and yellow bars is usually high. The amount of error varies among manufacturers. In a few cases, errors also exist in the green channel. When the red channel is not correct, the red bar in this pattern will appear to be overly saturated, and usually the yellow bar will appear to be orange instead of yellow. If you were to look through a red filter, a small error would look like this. An error much larger than this would have to be corrected in the design or calibration of the decoder. Once blue has been properly set, if you find that the red and/or yellow bars look overly saturated with red, the color control will have to be turned down. Making that adjustment will desaturate green and blue, but there is no alternative. Decoder errors are often designed into sets in an effort to make them unique in appearance. Changes are not consistent, often being different within a single manufacturer's product line. These inconsistent design changes contribute to NTSC's reputation of never twice the same color. There may also be errors in the green channel, although these are less common and are usually not bad enough to require a change in the color control. Your turn at adjusting the color controls using the blue filter is coming up. If you can, make sure all of the automatic color and tint functions have been turned off. If your set allows the choice of decoders, choose the comb filter or accurate decoding position. If there is an additional option to turn off the notch filter or trap, do so. We use the blue channel in setting the color and tint controls because that's where the largest visible change occurs with any movement of the controls. Once the blue has been set correctly, the red and green channels should also be correct if the decoder is functioning according to the rules of the NTSC system. Is your blue filter ready? It's your turn to look through the blue filter and make all of the bar patch combinations match in level. Now you can check the saturation of the bars containing red. Does the red bar look overly saturated? Does the yellow bar look orange? If so, reduce the color level to a point where the red is tolerable and the yellow bar begins to look yellow. Other colors will be displayed lower in level than intended by the video signal, but short of changing the design of the decoder, this is as much as you can do. One last check on program material. Does color saturation look high? If it does, we'll repeat the SMPTE color bar pattern so you can check your adjustments again. Then follow the color bar pattern with more pictures. Earlier in the adjustment process, we asked you to set the sharpness control at its lowest position. It needs to remain there for the following demonstration. The sharpness control adjusts the amount of detail enhancement or high-frequency peaking to be added to the video signal. In this picture, the transitions from the gray background to the black lines are clean. In most sets, increasing the sharpness control will add extra edges to at least some of the transitions in the picture, making them stand out. The problem is that you are adding information to the display that is not part of the original signal. Noise is also added to the picture when increasing the sharpness control. While this added noise may give the impression of more detail, it actually has little or nothing to do with the original signal or any real picture detail. In both cases, turning the sharpness control up to the point of adding false information is pushing it beyond its correct setting. The correct position of the sharpness control is just below the point where extra lines are being added to the picture. In most consumer sets, the correct position of this control is at the lowest possible setting. There are exceptions. Some sets won't allow the extra material to be removed, and others will significantly soften the picture at the low end of the control range. It's your turn to make the adjustment. If you're used to viewing TV with the sharpness control above its correct setting, you may find that the picture seems soft at first. Try not to increase the sharpness setting no matter what it looks like at first. You'll soon start to notice an increase in real picture detail which you never saw before. That's because it was obscured by false information added by the sharpness function. The picture will take on a film look, a smoothness not generally associated with consumer video pictures. Your image won't have that glaring look of inordinately hard edges and fixed pattern noise that you've probably been watching in the past. We've just taken you through the setup procedure for the 5 front panel controls found on most TV sets. The instructions should help you get a much better picture from your set. If you need to review any part of the narration, this menu will allow you to go back to any section you need. If you have a good idea of how to make the adjustments without the instructions, the individual test patterns are coming up next. That's followed by both test patterns and test images. Congratulations! You've now adjusted your TV to a higher standard. We're happy to have helped you take control of your audio and video system. You will find yourself enjoying your home theater a lot more now that it more accurately reproduces the source material. Don't forget to check all of the settings every few weeks or whenever you know you've changed something. You might want to set up a schedule on your calendar as a regular reminder to adjust your system with Video Essentials. This chapter opened with still frames of the test patterns needed to calibrate the user controls on an NTSC display device. Now that you've learned how to adjust the controls from earlier chapters, you'll find it easier to go directly to this section of the disc whenever you need to check the video adjustments. A couple of reminders. First, if your set has accidentally been reset to one of the high contrast factory presets, damage could occur to the picture tube in as little as 30 seconds when displaying these test patterns. It is important to quickly reduce the contrast control to a point below any visible blooming before going on with any of the other adjustments. Second, your set should be on for at least 30 minutes before making any final adjustments. What you're now seeing is a continuation of the image test section of Video Essentials. These are real-time test patterns needed for evaluating color decoder quality, picture resolution, flicker, and signal-to-noise ratio. The sample images you'll see following the test patterns are designed to challenge certain aspects of the display system. You'll find a more comprehensive set of test patterns at the end of this chapter. Assisting you in properly adjusting the front panel controls is as far as we can go with Video Essentials. There is one more important parameter that must be properly set to complete the process of obtaining the best possible picture fidelity from your set. That's the adjustment of the color of gray. It's not being detailed in this program because the adjustment requires a qualified technician with instrumentation. What is the color of gray and why is it important? Briefly, the black and white or luminance portion of the video signal contains the majority of picture information. It makes up the grayscale and picture detail. Low-resolution color is added to the black and white portion of the signal, making up the color picture you see on your set. If the black and white part of the picture is reproduced as anything but neutral in color on your set, its non-standard color of black and white will change the appearance of the color picture. If the black and white pictures shown here look blue to you, all of your color pictures will also be tinted blue. Some sets offer 2 or 3 options for the color of black and white. They are often labeled as high, medium, or low color temperature. Pick the position that produces the most neutral black and white. If the set is functioning correctly by the names of the labels, the low setting will be the best choice. Correctly setting the color of gray is a job for the specially trained home theater installation person. The test patterns needed for closely examining and adjusting the grayscale are included at the end of this chapter. Once again, do not attempt to go beyond the consumer-accessible controls without engaging qualified help.